This is the regression video on interpreting regression coefficients. In simple linear regression, the fitted model is sometimes denoted y equals alpha plus beta times x, sometimes by y equals beta naught plus beta 1 times x. This latter and equivalent notation being more easily extended to the case with multiple predictors. The regression coefficient beta gives the expected difference in outcome associated with a 1-unit difference in the predictor x. When beta equals 0, the line is horizontal and x has no impact on the outcome. The next two slides demonstrate why beta has the interpretation that it does. We've derived predicted values for two patients that differ by 1 on the value of the predictor. Here, one patient has x equals 10, the other patient has x equals 11. The predicted values are alpha plus 10 beta and alpha plus 11 beta, respectively. When the predicted values are subtracted, the alphas cancel, and a single beta is all that remains. The same idea applies to any two patients that differ by a value of 1 on x. Here we've derived predicted values for two other patients that have x equals 15 and x equals 16, respectively. Everything cancels as before. What this demonstrates is that beta is not only the expected difference in outcomes associated with the 1-unit difference in x, it's that this expected difference regardless of which patient is used as the reference. As a reminder, it's up to you to verify that the model is appropriate for the value of x upon which you've chosen to focus. Typically, this means that you have a reasonably large number of patients with values of x within that neighborhood. You'll sometimes encounter regression coefficients that are very small, that is, near 0, but statistically significant. The problem is usually that the predictor variable is on the wrong scale. For example, suppose you've modeled the impact of annual income on outcomes from a surgical procedure, your underlying hypothesis being that richer patients in general have more resources for support, and the support tends to improve outcomes. Rather than reporting beta as the change in outcome associated with a dollar difference in annual income, you should report it as the change in outcome associated with a $1,000 or even a $10,000 income difference. To do so, but multiply both beta and its standard error by the factor that you use to rescale the predictor. Or if you don't want to remember this, just rescale the variable in your input data set and refit the model. One final point. Strictly speaking, regression coefficients compare expected outcomes of two different patients, namely two patients that differ by a value of 1 on the predictor. Often people use the shorthand of the change in the expected outcome associated with the 1-unit change in x. It's important to recognize this doesn't necessarily mean that intervening on a patient and changing the level of x will have any impact on y. It might or it might not. To determine which is the case, cross-sectional data are inadequate. Instead, what you'd have to do is intervene and then follow patients over time.